Now let's go over how to perform constructions to show a reflection. When reflecting a figure, reflect the vertices first, then draw the sides. With the compass and straight edge, reflect quadrilateral ABCD over line L, and label the vertices of the image A', B', C', D'. We first have to begin by reflecting one of the points about line L. Let's go with point D because it is the one that is closest. So we'll put the tip of the compass right at point D, and we'll extend it out so that it is just beyond the line of reflection L. And I'm going to change the color so that it doesn't conflict with the line of reflection, which is black. And we first draw this bigger arc because we're creating a perpendicular line to the line of reflection in order to get the reflection location accurate. So the next step is going to be to move the tip of the compass to be right at the intersection point of the line of reflection in the first arc. And then we're going to draw in the arc here, and then we're going to go up to the other intersection point of the first arc and the line of reflection. Now we can draw this in. And then if we connect that intersection with our line that we have, so here's the line that we're going to use to reflect point D. And also, since A lies on the same line as point D and this guiding line of reflection, we don't have to redraw it or reconstruct it because it'll give us the same exact line again. So let's move our straight edge out of the way and realign our compass and get it horizontal. And we have it at point D, and we're getting it to the line of reflection. So then we're going to move the compass so that its tip is on the line of reflection. And we're going to draw an arc in. We're going to draw it in purple this time so that we don't confuse it with what we used before. So then this point right here is going to be point D'. And again, since A and D are on the same line, let's use the compass then to extend out to our line. And then we can slide it and move it to where we need it to go. So then this intersection point right here is going to be point A'. And next we're going to follow similar steps to reflect point C about line L. So let's first line it up and make it slightly longer than our line of reflection. I'll change the color to be green. And here we see where the line of reflection intersects the arc that we just drew. So now let's realign our compass and straight edge so that it aligns with one of those intersection points. We're going to make another arc out here. We'll go down to the other intersection point of the arc and the line of reflection. I can already see where they're going to intersect. We're going to use that to draw our perpendicular line to the line of reflection. That'll be the guide for points B and C. Now we can use this line. We're going to get it even with C to the line of reflection. And then we're going to move that here to make point C. So we made it in purple so that we can distinguish where the compass actually intersects our guiding line. So this will end up being point C'. And next let's move our compass back to point B make it directly horizontal, straighten it out till we get to the line of reflection right there. And then we're going to take our compass and move it so that it's on the line of reflection. And here's where point B prime is going to be constructed. B prime. Now we have our image, quadrilateral A prime, B prime, C prime, D prime. This is an example of reflecting across a vertical line. Of course, we can superimpose an XY coordinate plane on the figures. How should we do that? Where should we position the origin? Take a moment to pause this video and think about it, and when you're done, unpause it. There are different strategies for superimposing a grid. If the line of reflection is vertical, then having this line coincide with the y-axis is generally a good strategy, as shown in the figure below. Having the x-axis coincide with sides BC and B'C' has some advantages too. Notice if we reflect across x equals 0 or the y-axis to map quadrilateral ABCD to quadrilateral A prime, B prime, C prime, D prime, it's written as a reflection across x equals 0, colon, x comma y becomes negative x comma y. Notice the x coordinates, the sign changed to become the opposite, which is why we have the negative out in front, and the y coordinates did not change at all. Next, let's try another reflection construction. With the compass and straight edge, reflect quadrilateral ABCD over line S, and label the vertices of the image A prime, B prime, C prime, D prime. Notice that our line of reflection, line S, is on side BC of this quadrilateral. Therefore, points B and C, their images will remain the same as the pre-image. So let's put our new points in here for B prime and C prime. And now we can use the compass and straight edge to determine what A prime and D prime will be. So we're going to put our compass at point A. We're going to rotate it horizontally and straighten it out so that it is just beyond our line of reflection, and we'll change the color. We'll make it blue, and we can see where it intersects our line of reflection in two places. First one looks like right here, and the second spot is right about here. And here's where the intersection is going to happen, right in that location. Okay, so we need to rotate our ruler. Not exactly. It's not, there we go. There's 90 degrees. And here we can see where this line of reflection is going to be. There we go. And then we put our compass tip right there, and we'll bring it to be horizontal and bring it back into the line of reflection. And now we'll move this over so now the point is on the line of reflection, and we're going to change the color so that this arc that we're drawing represents our point for A prime. And now we're going to follow the same steps for D. So we're going to line up D to be just beyond the line of reflection. Right there should work. You can change the color so that it doesn't overlap with the blue or the purple. And we can see the 2 points where the line of reflection intersects this arc. Okay, so there's going to be the intersection point, and we're going to align it with D. Here we go. Oh, there's our straight line. And now we need to bring our compass to where D is. Make it go horizontally and have it line directly up with the line of reflection. And then we're going to translate it down to the line of reflection. Again, we'll change the color. So this is where point D prime will be. And we can connect our image points to make our quadrilateral A prime, B prime, C prime, D prime. This is an example of reflecting across a horizontal line. Of course, we can superimpose an XY coordinate plane on the figures. Choosing the x-axis to coincide with the line of reflection is an obvious choice. In the previous problem with the vertical axis as the line of reflection, we chose to position B at -7, 0 and C at -3, 0. Let's try to use the same strategy with this one. As stated, points B and C are remaining at -7, 0 and -3, 0, respectively. So therefore their image points, which is B double prime and C double prime in this diagram, also have those same coordinates, -7, 0 and -3, 0. But now let's look at point A. It's at -5, 4, and when we reflected it over the x-axis, it's at -5, -4. And then point D is at -1, 4, and point D double prime is at -1, -4. So the reflection across the x-axis, or y = 0, that maps quadrilateral ABCD to quadrilateral A double prime, B double prime, C double prime, D double prime, is written as a reflection, capital R, across the line y = 0, such that x, y becomes x, -y. Notice that the y coordinates switched signs and the x coordinates remained the same. Here's the summary of the two reflections of the quadrilateral ABCD, one across the y-axis and the other across the x-axis. So our pre-image, when we reflected it across the y-axis, or x = 0, our coordinates x, y became -x, y. Y coordinates stayed the same, x coordinates switched signs. And when we reflected across the line y = 0, or the x-axis, our pre-image points to our image points went from x, y to the x coordinates stayed the same, but the y coordinates switched signs. We can also show horizontal and vertical reflections in a coordinate plane using a Desmos simulation. So if we click on this link, it'll take us to the simulation. If it doesn't appear in this format and it shows up like this, you can choose the settings command and make it a little bit bigger in terms of print, and it'll make the lines of our objects thicker as well. So let's first look at what happens if our line of reflection is x = h, or this vertical line. So we have a vertical line, and as that vertical line of reflection approaches the pre-image, the mapping to the image requires less space. On the other hand, as the line of reflection becomes farther away from the pre-image, the mapping to the image requires more space. And we can play it a little bit so you can see more of what we're talking about. Also, as you're watching it, throughout the reflection across vertical lines, the y coordinates do not change at all. The y coordinates corresponding to the top and bottom of the pre-image are exactly the same in our image. So our base here is always has y coordinates of 1. And the same is happening in the image coordinates. They always have a y coordinate of 1. If we now switch to a horizontal line of reflection, we can observe that as the line of reflection approaches where the pre-image is, the mapping to this image in green requires less space. On the other hand, as the line of reflection becomes farther away from the pre-image, the mapping to the image requires more space. Throughout the reflection process across horizontal lines, the x-coordinates are not changing. Notice that wherever I have this horizontal line, the x-coordinates of the pre-image and in the image are remaining the same. So we're at x-coordinates of 1 and 5, and here we're still having x-coordinates of 1 and 5. It's the y-coordinates that are changing when we have a horizontal line of reflection.